All right, so here we go with part 2 of section 2.5. We're solving systems of equations using a matrix algebra approach. So I'm working on this system. First thing I'm going to do is I'm going to rewrite it as a matrix. I have my coefficient matrix, 2, 5, 1, 4. I have my variable matrix, x, y. And this is equal to the constant matrix, 15, 9. That's the A. That's the B, that's the X. I have A times B is equal to X. X is going to be equal to A inverse B. That's the rule for matrix algebra. So that's what I'm going to go ahead and do. All right. In order to do that, though, I got to check all this stuff into my calculator. So over here, second, matrix, edit. Matrix A is a 2 by 2. The entries are 2, 5, 1, 4. Quit out of there. Back to matrix, over to edit, down to matrix, over to edit, down to matrix B. It's a 2 by 1. The entries are 15, 9. And I quit out of there, and then I'm going to redo that command right there. And I get 5, 1. So I get that X is equal to the matrix 5, 1, which means that the variable X is equal to 5, and the variable Y is equal to 1, and I'm done. All right, another one. What's the matrix A? A is going to be the matrix 2, negative 4, 1, negative 2. What's the matrix B? 13, 1. And then what will X be equal to? I'll tell you in a second. Matrix, edit. Matrix A, it's a 2 by 2. The entries are 2, negative 4, 1, negative 2. Okay, quit out of there, go back to matrix, over to edit, down to B. Matrix B is a 2 by 1. The entries are 13, 1. Quit out of there, rerun that same command again. Wait, what? What does that mean? Oh no. Okay, so here's the downside to matrix algebra. When we were solving systems using the Gauss-Jordan or the by-hand technique, there were ways to tell from the math whether you had no solutions or whether you had many solutions. Okay? Remember, no solutions is when we saw something like 0 equals 1, and many solutions is when we saw something like 0 equals 0. With matrix algebra, anytime I see that error right there, anytime I see that singular matrix error, I know that one of these two things has happened. That I either have no solutions to my matrix algebra, or I have many solutions. And this, in my opinion, is the weakest thing when it comes to matrix algebra. When I did the Gauss-Jordan approach, I could look at the result on the calculator and I could tell whether or not it had no solutions, many solutions, or a solution. With this, I can't. So while it is an approach and it can be used to solve systems of equations, it has a limitation. It has several limitations. Matrix algebra is only good if you have the same number of variables as equations. So that means 2 variables, 2 equations, 3 variables, 3 equations, and so on. It's only good if you have a unique solution. And that, in my opinion, makes it a very limiting technique. Right? So while we cover it, and while it does have application, and it does have use, and I get that in certain situations that's the best way to do things, it really doesn't have a lot of use. I would make the following argument. I would use matrix algebra to solve linear systems if I had to, but I would prefer to use the Gauss-Jordan RREF. Right? Now, when you're doing the homework or when you're taking the exam, there are certain problems where it's going to ask you to use this technique or that technique. But if the problem doesn't say which way to do it, choose your own way to do it, right? You've got 3 options for solving systems. You've got the by hand. You've got the, I'm just going to call it the RREF command of your matrix A. And then you have matrix algebra. Okay? In my opinion, this one's the best. Because it works no matter what, as long as you remember how to read the matrices. When you see 0 equals 1, that row of zeros across the bottom matrix, or when you see that row of all zeros across the bottom matrix, if you know what that means, this is probably the best way to solve these things, the fastest. This would be the slowest. It's also the one with the most chance for error. So you have many possibilities for error, many chances for error. We'll say it like that. Because you're touching every single equation many times. And this one over here, yeah, matrix algebra is good, but it's very limited. It only works when it works, and when it doesn't work, it doesn't tell you why it doesn't work. It can't tell the difference between no solutions and many solutions. So just be careful. Use this one when you can. Use the other 2 when you have to. But just recognize that there's a lot of tools out there to get the job done. Some are just better than others. All right, this brings us to the end of section 2.5. We have one more section we have to cover. It's 2 point something. It technically isn't in the book, so it won't be any book homework for it, but I will be covering it in the next set of videos. Alrighty, have a good day.